Hello, today we're going to talk about nonlinear functions and how to determine if something is nonlinear. And there'll be three areas that we'll be working with. We'll be working with a graph, an equation, and a table. So you'll want to take notes in your spiral notebook. And we're going to go ahead and start with a graph. So how do you know if a graph is nonlinear? Well, looking at this example here, we have three different types of graphs. So we want to know which one appears to be nonlinear. So a linear, if you look at the word linear, it has the word line in it. So linear graphs are lines. So if I look, number one, the first one is definitely a line. So this is a linear graph. The second two don't have lines. So I look at the word nonlinear and I see the word no line in it. So that means 2 and 3 are nonlinear. So for a graph to be linear, it has to be a line. Looking at the next example that we have this collection of data points, and we want to know if it is linear, if it's a linear relationship or a nonlinear relationship. So one way we can do it is, since we know how to determine if a graph of a line is linear, if a graph is linear, we can go ahead and graph that. So I already have x and y here, so I'm just going to quickly graph it. Oops, it shifted a little bit. Sorry about that. So I have 2, 4 is my first point, and 4, 8 is my second point, and 6, 12 is my third, and 8, 16, which would be up here, is my last. And if I go ahead and connect those points, they do form a straight line. So does the function appear to be nonlinear? We would say no. It appears to be linear. Now, the problem is I don't always have graph paper with me. So is there another way I can determine if this table is linear? And that is yes. So what you want to do for that to determine if a table is linear is you want to look at how the y is changing each time over the x. So if I look, I can see that y increases by 4, so that's the first part, and then x increases by positive 2. So that is what we call the change in y compared to the change in x. And that should be equal every single time. So it should always be 4 over 2, or this reduces to 2 over 1. So let's check them. So we have 8 to 12 is positive 4, and 4 to 6 is positive 2. That equals the same. And then 12 to 16 is positive 4, and 6 to 8 is positive 2. So we can say my rate of change is 4 over 2. So it's a little different than proportional. Proportional, you're just looking at x to y, so you're looking at 2 to 4 and 4 to 8 and 6 to 12 and 8 to 16. Linear, you're looking for the change in y compared to the change in x. So make sure that you have that written down. This is for a table. So make sure that you have that in your notes. And then we have an equation. So for an equation to be linear, I could again plot these points, but I don't always have graph paper with me. So there are a couple of rules and things that you look for when you're talking about linear equations, and that is that there aren't any exponents. So since this has an exponent, this makes this nonlinear. And it could be numerical exponents, or you could even have something like y equals 2 to the x. That would be nonlinear also. So if I look at b, I don't have any exponents. I just have y equals negative 3x plus 2. So this is linear. Then I can look at my tables. I learned in the last example how to determine if it's linear. So it's the change in y over the change in x. So if I look, from 10 to 7 is negative 3. I'm subtracting 3. and 2 to 4, I'm adding 2. So that should be that same ratio the whole time, or a multiple of it. So 7 to 4, I'm subtracting 3, and 4 to 6, I'm adding 2, and 4 to 1, I'm subtracting 3, and 6 to 8, I'm adding 2. So every single ratio equals -3 over 2, so this one's linear. Now if I look at the next one, my change in y goes from 2 to 4, that's +2, and then my change in x is 1 to 4, that's +3, so they should all be 2 to 3. And then 4 to 8 is +4, and 4 to 7 is +3. So now I can look right now and say these are not equal. I don't have to go any further. I know that this is nonlinear. So go ahead and pause the video and answer these questions and then play it back and I'll give you the correct answer. So you should have tried these on your own. Looking at the first one, we have y equals 17 minus 4x. There's that exponent that's a variable, so that makes this one nonlinear. And then don't worry about the parentheses here. Actually, you could go ahead and solve this by distributing the 2. And then you would get y equals 2x plus 18, and that's linear. Then again, looking at these, we're looking for the ratio. So the change in y is 2, and the change in x is 3, so it should all be 2/3. So 5 to 7 is 2, 6 to 9 is 3, 7 to 10 is 3, and 9, 10, 11, 12 is 3. So because those are not equal, this is nonlinear. And then -2 to 1 is +3, and 6 to 7 is 1, and 1 to 4 is +3, and 7 to 8 is 1, and 4 to 7 is +3, and 8 to 9 is 1. So this is linear. They have a ratio of 3 to 1. Okay, we have this word problem here, and we want to decide if it's a linear or non-linear relationship that they're explaining. So it says a single cell divides to form 2 cells after 1 minute. All cells formed after this also divide in 2 every minute. A function relates time in minutes to the total number of cells. So we have the time and then the number of cells. So if I look, I can say in the first minute there's 1 cell, and then in the second minute that cell splits into 2. And then in the third minute, I end up with 4 cells, and then in the fourth minute those split, so each one splits and I have 8. And then in the fifth minute, I have 16 cells. So the first one splits into 2, and then each time those split. So we want to see if this is a linear relationship. So I look at my change in my y, which would be my number of cells, my dependent variable, and it's 1 over 1 to begin with. And then it's 2 over 1. And I can automatically see that these are not equal ratios. So this is nonlinear. This is not going to be a linear relationship. Now I can look at this example. John mows lawn. He charges $15 per hour. So that's $15 per hour. And a function relates the number of hours John works and the amount of money he earns. So that's the amount of money he earns. So we'll make that A. Is the function nonlinear? Well, I can look at this and I can see in my equation that there aren't any exponents. So I'm thinking this is going to be linear. But if you're not sure, you can always create a table. So the amount of money he earns depends on how many hours he works. So this is really my X and my Y if I was graphing it. So if he doesn't work at all, he doesn't make any money. And if he works 1 hour, he makes $15. And if he works 2 hours, he makes $30. And if he works 3 hours, he makes $45. And then I can look at the change in my dependent variable, my y, my amount, which would be $15 for every 1 hour, and then $15 for every 1 hour, and $15 for every 1 hour. So yes, this is linear. Now in your spiral notebook, you should be able to identify how to determine if something's linear or nonlinear using a graph, an equation, and a table. So make sure you have that filled out in your spiral notebook.